All right, so we've got a new week. We got a whole new concept. So we're going to be talking about volume, and specifically, we're going to be talking about volumes of cylinders. And now, volumes of cylinders are super, super important because when you talk about like a monster can, we're going to be talking about how much stuff, how much liquid is inside that monster can. Okay, so it's the amount of stuff inside a thing, I guess. And so the things that we're going to be talking about are going to be mathematical shapes, they're going to be geometrical shapes, and the amount of space inside is the volume. And so our units are going to change. We've been used to like inches, centimeters, things like that. And then when you talk about area, we've been talking about inches squared, centimeters squared, square feet, things like that. Now we're going to bump it up a dimension. Okay, we're going to be talking about cubic centimeters because every single unit of volume is measured in cubes. Like how many cubes, like little dice, you can fit inside of a shape. Okay, and so if each, they call them a singular for dice is die. One die, let's say it's 1 unit by 1 unit by 1 unit. It's how many of those fit into a particular shape, and you can have pieces of them too. Okay, so a couple of things that we need to know before we do any of this is all going to be review from last year. You have these videos available to you uh, in the HyperDoc, and they're all from 7th grade. Okay, so I know that you've done this before because we've all done 7th grade. All right, so you need to know volume of a prism. Okay, and so the way that I define volume of a prism, it's not easy, but it's simple. Okay, so the volume of a prism. Okay, so I'm going to say that the volume of a prism, the volume equals, now this is where things get a little bit different. This is where things are a little bit different than maybe you've seen before. Because before you may have seen, well, this one is this, the volume of this is this, the volume of this is this, the volume of this is this. You know, cubes are different than rectangular prisms, are different from triangular prisms, are different from, hexagonal prisms. But here, I'm going to keep it consistent and say that the volume of any prism, is the area of the base times the height. No matter what the base is, no matter what the base is, it's the area of the base times the height. For example, if I were to have a rectangular prism, okay? And so what that means is like a rectangular prism is like a book. It's like a book. If you look at a book, you got all the pages. That's the height. Okay, the height of the book is how many pages. And then the base is whatever shape the book is in. And so this is your base. Okay, and the cool thing about a prism is that it's the same on the top as it is on the bottom. So if I were to bring this down, the dashed lines means that it's just behind, like it's inside. You don't really see the line because there's a surface there. It's behind the surface. So you can see that the base here is the same as the base here. And so this time it's a rectangle. Let's see, a rectangle has a particular length and a width. So a particular length and a width. And so in order to get the area of the base, you multiply the length times the width, whatever that is, multiply it by the height. Okay, so let's throw some numbers in here just to practice and to make sure that we're all good. Here, let's say that the length is 3. Let's go inches. Let's go, the width will be 5 inches, and the height will be 10 inches. Okay, just to make the numbers easy, we got length is 3 inches, width is 5 inches. That's of the base. And then the height of the prism is 10 inches. And so if I want the volume is area of the base, which is that 3 inches times the 5 inches. So 3 times 5. And you know what? I'm going to even insert and, include the inches. just to make sure that we understand where the units are going to come from. So 3 inches times 5 inches. And then we take that and we multiply it by the height. And the height just happens to be 10. So we multiply that by 10 inches. Okay, so again, if you recall, this is the area of the base right here. That's the area of the base. And then that's the height. Okay, so 3 times 5, well, 3 times 5 is 15. So the area of the base is 15. And now if you take inches times inches, that's inches to the second power. Okay, because if you have x times x, it's x squared. Same thing here, inches squared. Every time you have an area, it's inches squared times 10 inches. Now, again, you have to be pretty good with your exponents up to 3 at this point. And so now we're going to take this and we're going to multiply these together. Okay, so we've got 15 inches squared times 10 inches. That's going to give us 150 because 15 times 10 is 150. And then you have inches times inches times inches. That's 3 of them. So now we're going to have inches to the third power. And so the area of the base times the height. The area of the base happens to be 15 inches squared, and that's all this right here. That's the base. Again, the base is also on the bottom, but it's the same shape. And then the height is the height of the prism. The height is the height of the prism, and that's so super important. Okay? And it doesn't matter what shape the prism, like it doesn't matter what shape the base is. It doesn't matter what the shape is. So we could have some weird shape. Let's say we had an octagonal prism. I might be messing myself up here by doing this, but we're going to try it. Here we have an octagonal prism, and then that octagonal prism besides looking like a jellyfish, it's an octagonal prism. So it looks like a stop sign. Like if you had a stack of stop signs, that's what this would look like. It would look like a stack of stop signs. Okay, and so again, we would look at the volume as volume is area of the base times the height. Now, I'm not going to get into how to get the area of an octagon right now because that's not important. But I will tell you that the area of the octagon, area of all of this, the area of the base, is 120 centimeters squared. So I'm going to tell you that the area of the base is 120 centimeters squared, and I'm going to tell you that the height is 5 centimeters. Okay? So in order to get the volume is the area of the base, which is 120 centimeters squared, times 5 centimeters. Whoa. Okay, so 120 centimeters squared times 5 centimeters. Okay, so we just get the area of the base times the height. You multiply these together. That's going to give you 600. Now remember, centimeters squared is centimeters times another centimeters. So that's going to give us centimeters cubed. Okay. So, not bad. I mean, the area of a prism, again, prisms are just like the same thing, the same shape, stacked all the way up. Here, this is like a book. This is like a stack of stop signs. Now, again, how does that fit in? Well, we've got cylinders, and cylinders are nothing more than, and I'm going to put this over here, cylinders are nothing more than circular prisms. Okay, so cylinders are circular prisms. So if I have a circle here, I bring it down, Okay, so again, this is now a circle as the base, and we have a height. And well, now that kind of begs the question, do we remember how to get the area of a circle? And that's going to be something that we're going to discuss, because we got to know how to get the area of a circle if we're going to get the volume of a cylinder. Okay, so remember, because it's the area of the base, this time the base is a circle, so let's remember what the area of a circle is. Here we go. So remember, area of a circle equals this number pi, which is one of my favorite numbers ever, times the radius squared. Now, if you were in my class last year and when we talked about this, or maybe you'll be able to see it on the video, is that a circle, so remember, so a circle looks like this, and then we can fit some squares in it, but how many squares of length r, the radius, fit in it? There's about a little bit more than 3 of them, and so there's actually 3.1415926 of them, about that. Okay? So that's why we multiply it by pi, because this is how many squares of this side length fit into a circle. That's where pi comes from, sort of. So if I were to give you a circle, and if I were to give you the radius, please remember the radius is the length between the center and any point on the circle. Because if you have the center, you can say it's the same to any point on the outside of the circle. This is called the radius. And I'm going to tell you that the radius, let's say, is 5 feet. 5 feet. So the radius being 5 feet means that we take 5, and that is our r. Okay, so that's what we substitute in for r. So in order to get the area, we're going to take pi, substitute 5 in for r. I'm going to go 5 feet in this case, squared. That means you multiply it by itself. Okay? So what we need to do is we need to take 5 feet and multiply it by itself. So here, this is pi times, well, 5 times 5 is 25. Feet times feet is feet to the second power, so feet squared. Okay. Now here for pi, what I'm going to have you do is I'm going to have you use, if you don't have a calculator that has pi, which I'm just using my phone has pi, but you have to turn it sideways. And so if you don't want to use pi, then what you do is you're going to use 3.14 for pi. So this is going to be now approximately 3.14 times 25 feet squared. And then I'm going to have you round to the nearest hundredth. So that's 2 decimal places. 2 decimal places. So here I had the pi button on my calculator. So that gives me, when I multiply these together, that's 78.54 feet squared. And it's approximately. So you have to use the wavy equal sign. Okay? Because it's not exact. Notice it once we put in 3.14, it went from being exact to approximately. So you have to make that equal sign a wavy equal sign. All right, so, and now that is the area of that circle. That's the area of that circle. Okay, so here's what I'm going to do. I'm going to move this over. Because there are some times where you're not given the radius. Sometimes you're not given the radius. Sometimes you're given what's called the diameter. And if you're given the diameter, what you're going to need to do is use, oh man, okay, well then Find an online calculator that has a pi button. They're called scientific calculators. Well, that's just unfortunate. Is it at least close? Is there a close one? I mean, or they? Okay, all right. Get something with a pi button. Borrow somebody's phone or something. All right. Or you know what? If you have a calculator that has a pi button, you're already set. If you don't know how to use your calculator and get the pi button, email me and tell me what kind of calculator it is. Send a screenshot or take a picture of it, and I'll be able to help you out. Okay? Or Miss Bree can help you out as well. Okay? All right. But again, they have online calculators, so you can always go to the online calculator and then do that thing. All right, here we go. So sometimes, again, you'll be given a circle, and you're not given the radius. You're given what's called a diameter. And the diameter is the distance straight across through the center. And so let's say that, so this is the diameter. And let's say that let's say that the diameter is, let's go with, I don't know, 12 units. I'm just going to leave it as 12. Okay. So 12 units, whatever the unit is, let's say there's 12 of them. Okay, so if 12 is the diameter, remember the radius is only from the center out. So if I go from the center out, that's literally just half of the diameter. So if the whole diameter is 12, then the radius is only 6. And so in order to get the area of this circle, we take pi, we multiply it by 6 squared. 6 units squared. Okay, so this will be pi times, now 6 times 6 we know is 36. Okay, so you take your calculator, 36 times pi. Now, once you use once you use your calculator, it stops being equal and it becomes approximately. Okay, so it's approximately, and again, I want you to round to 2 decimal places. And this one's going to be weird because it's going to round, because the last number is going to be a 0. When we round, it rounds up to 10. So it'll be 113.10, because it was 0.097. And this will be units squared. Units squared. Okay, so sometimes you're going to be given the radius. Sometimes you're going to be given the diameter. And you have to be able to calculate the area from there. Now, that goes right into what we're going to be doing with the cylinder here. Okay, so remember, volume of a cylinder is just a circular prism. Okay, so I'm going to put up here, volume of a prism is the area of the base times the height. And for a cylinder, the area of the base is the area of the circle, which is pi times the radius squared. Okay, in this case, that's what it is. So that's something to keep in mind. That's a thought bubble. Okay, so that's something to keep in mind. So volume equals the area of the base times the height, and in this case, the base is pi times the radius squared. Okay, and you're going to see this done 2 ways. You're going to see it with a picture, and then you're going to see it with a verbal description. So, with a picture, here's your picture. This time I'm going to turn the cylinder sideways. Yes. No. Okay. So here we're going to turn the cylinder sideways. And we're going to calculate its volume. Okay, because cylinders aren't always straight up and down. Sometimes they're laying flat. Okay? So in this case, I'm going to give you the radius. The radius is going to be 3 inches. The radius is going to be 3 inches, and the height is going to be 11 inches. Okay? So the radius will be 3 inches, and the height of the prism will be 11 inches. Okay? Because remember, the height of the prism is how big the stack is. Here we happen to have the stack going sideways, so the height is side to side. Okay, so here, we're going to go step by step. Volume of a prism is area of the base. Okay, in this case, the area of the base is pi times the radius squared. Pi times the radius is 3 inches, so 3 squared. This is the area of the base times the height, which is 11. And remember, this 3 is 3 inches. This 11 is 11 inches. And here we go. So this will be pi. 3 squared is 9. So times 9 times 11. We're going to use the pi button. So take 9 times pi. We're going to get, now remember, we're rounding to the nearest hundredth. Rounding to the nearest hundredth. Oh, wait. It ceases to be, and now it's approximately. And now when you round, this is super important. When you round, I want you to wait and round at the end. Wait and round at the end. Okay? Because if you round in the middle, it might not work. Kind of like using the 3.14. When you use the 3.14, you don't get one of the answers that are given. Same thing, if you try to round in the middle of the problem, you might not get the answer that's given. Okay, so wait to round until the end. Super, super important. Wait to round until the end. Okay, so I'm going to go out a few more than 2 decimal places here. So 28.274334. That should give me enough to be able to round correctly in my final answer, times 11. And notice I did a bunch of decimal places because I'm not rounding yet, not rounding until the end. You take that, you multiply it by 11. That gives us a volume of approximately, now is when you round, 311.02. Now here we had inches times inches times inches. So that's inches to the third power. Where do I get the exponents? So the exponents come from here. Okay, came from the area of a circle. Came from the area of a circle. And so if you want me to keep going, then I'm going to say in the video about area of a circle, it talks about where the exponent comes from. Because it's really like if you have a circle, in order to get the area, you have the radius, we just use squares. We make squares. And you may remember this from last year. Each of these squares is r by r. So if you take off this outside stuff, that means that there's this outside stuff counts for approximately 0.86 of a square. And so you end up with 3 whole squares and 0.14 of a square. So, but each of so this r squared represents the area of one of these squares. But anyways, it came from the formula here. That was the area of a circle. That's where this one came from, because I'm calculating the area of the circle. All right. Now, what if, oh, by the way, so this is your answer. Yeah, this is it. That's your answer right there. And so you can see that the steps are, there's not a lot of steps, but you have to understand what you're doing in order to be able to do those steps. So, where did I get the 3? Oh, that. Okay. So if I were to write this in, then this would be 3 inches. So here, let me put it in. This would be 3 inches squared. Okay, inches times inches, when you square that, that gives you inches squared here. Remember, this is also inches. And so you have inches squared times inches. So that's, again, remember, inches squared is inches times another inches, which is where we get the inches to the 3rd power. And it goes back to when we did this right here. See, inches times inches gives you inches squared, times another inches is inches cubed. Same thing when we did centimeters. It's centimeters squared times centimeters is centimeters to the 3rd. Okay, same kind of deal. And so for the next one, I'll put the labels in, and you'll see where it came from. All right, here we go. So last one, because really there's only 2. Well, no, we'll do one more after this, which with the verbal description. So if you have a cylinder that goes this way, okay, and here you're given the diameter, and here you're given the diameter, and the diameter is 14 millimeters. The height is 5 millimeters. And so the diameter is 14 millimeters. The height is 5 millimeters. Then we have to calculate the volume. Okay, so here we go. Volume equals, now area of the base is pi times 4. Whoa, it's not 14, is it? It's not 14. Because this is the diameter. We don't want the diameter. We need the radius. And so what we need to do is we need to take this diameter and cut it in half, because I only want half of it. And so that would give us 7 millimeters as your radius. Okay, don't get caught up with that. Keep that in mind. You need to use the radius. So this will now be 7 millimeters squared times 5 millimeters as your height. Okay, so this 7 millimeters is your radius. Okay, so now here this is going to be pi. If you take 7 millimeters and square it, 7 times 7 is 49. Millimeters times millimeters is millimeters squared times 5 millimeters. Okay, get your calculator out. 49 times pi. This is now approximately 153.93804 millimeters squared times 5 millimeters. And then this is going to give you a final answer of 769.69. Remember, rounded to 2 decimal places. And now you have millimeters squared times another millimeters. Remember, millimeters squared is millimeters times another millimeters is millimeters cubed. To the third power now, because you have 2 and then 1 more. Now, sometimes you'll be given a verbal description. Oh, by the way, does that answer where we got the 3? Does that make sense? As an exponent? Okay, good. All right, so now sometimes you're going to be given a verbal description and you're not going to be given a picture. Okay, so if that happens, then your problem will look something like is radius is 4 meters and whose height is 5 meters. So volume of a cylinder whose radius is 4 meters and whose height is 5 meters. What you need to do is you can either draw a picture or you can refer back to the formula. So remember, volume is the area of the base times the height. And in this case, the area of the base is pi times the radius squared. Okay, so remember, radius is r, and the height is h. So we take 4, substitute it in for r, so we get the area of the base. So volume, whoa. So volume equals area of the base, which is pi times 4 meters squared, times the height, which is 5 meters. So again, this is pi times, and this will give you 16 meters squared times 5 meters. Take your calculator, take 16, multiply it by pi. That's going to give you 50.26548 meters squared times 5 meters. And this last step is where you round. So this will now give you 251.33 meters cubed. Again, do not round until the end. Okay, so if you're given a verbal description, all you need to do is take those numbers, make sure if they give you a diameter that you cut it in half to get your radius, and remember what they represent in letters and use those to substitute in the equation or in the formula. Okay, I'm going to pause. Are there any questions? All right, so it seems I don't see anything in the chat. I don't see any hands up. So I'm gonna suppose that you're ready to start doing some of the practice. So I'm going to release you to do your hyperdoc, do your practice. If you wanted to start on the check for understanding, if you think that this totally makes sense and you're ready to go, then try the check for understanding. You can always edit your responses later. So please do your best. Make sure you're working after this. And yeah, so when you do your practice, come back on Wednesday and we will answer some questions. All right, I'm going to